Hello again. So now that we've had a chance to look at both factored form and standard form and their features, I think today we need to review how to go between factored form and standard form. We actually did this before the closure briefly, but I think we should review it now. So remember, factored form is A times an expression x plus or minus p times another expression x plus or minus q, where p and q are two numbers that help us find the x-intercepts. And standard form is ax squared plus bx plus c. So besides the fact that they both have an a in them, which actually is the same a value for each of them, there's not much else that they have in common visually. So to convert from factor form to standard form, we're going to use either double distribution or the box method to multiply and rewrite the factored expression. So like I said, we have done this briefly before, but I think this will be some good review and we're going to practice together. So we're going to use either double distribution or box method, and just like before, it is your choice which strategy you'd like to use. They both accomplish the same goal, which is multiplication. So I'm going to do example 1 with the box method and example 2 with double distribution, and then of course, however you choose to do this moving forward is all good. So example 1, we want to convert y equals x plus 4 and x minus 6 to standard form. So I'm just going to leave myself some space there to write my standard form. And I'm going to use the box method. So this is two binomials. So each binomial gets two spaces. So I'm going to have x plus 4 and x minus 6. And remember, we multiply the outsides of those boxes there. So x times x is x squared. X times 4 is 4x. X times negative 6 is negative 6x. And negative 6 and 4 make negative 24. So I'm just going to bring everything out, string it all together. And it looks like I have two like terms here, this plus 4x and this minus 6x, combined to make a negative 2x. So I'll have x squared minus 2x minus 24 as my standard form version. Now you might be saying, well, that's great. It looks great, but how do I know if it's correct? So one way we can check our work is to use Desmos. So if I check out Desmos, I've got both equations here, and I've got my original factored in red, and if I put my standard form equation, it should give me the same exact parabola, which it does. It's the same exact parabola as it was with the red, just one right on top of the other. So Desmos is an awesome tool to check just visually to see how you're doing there. So let's do example 2 using double distribution. And example 2 also has this a value, negative 2, out in front. Example 1 had an a value of 1, a ninja 1, but we didn't need to multiply by it because multiplying by 1 doesn't affect anything. So what I'm actually going to do is I'm going to multiply these pieces first, and then I'm going to worry about that negative 2. So I'm going to rewrite this, just give myself a little bit of space. Negative 2 times x plus 1 times x minus 5. And so if we're going to use double distribution, I'm going to start by distributing x to x and negative 5. So that will give me x squared, and x times negative 5 is minus 5x. And then multiplying 1 times x and 1 times negative 5 will give me plus 1x minus 5. And so all of the work that we just did there, I'm going to enclose in its own set of parentheses and put that negative 2 right in front of it because we haven't done anything with it yet. We're kind of just doing one piece of the multiplication, but this was the double distribution that we talked about earlier. So if that was all that we had there when we used double distribution, that would be almost it. We just have to combine some like terms, which I'm going to do now. Negative 5x and 1x combine to make negative 4x. So I have negative 2 times x squared minus 4x minus 5. Now, I'm almost there. I just need to distribute this negative 2 to everything inside. So that'll give me negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x is positive 8x. Negative times a negative makes that positive. And then negative 2 times negative 5 would be a positive 10. So I've got my standard form equation right there. So if you have an a value that's not equal to 1, so if you have an a value that's not equal to 1, I'm going to suggest that you multiply it last. After you multiply the other two terms, I suggest you multiply that a last, just so that you can focus on everything else and you don't get things all mixed up in there. So there are some questions down here for you to try on your own. What I'm going to do is I'm going to ask you to pause the video and try these out on your own, and then come back and check your answer. So if example 1 and 2 went well for you, whether you use double distribution or the box method, go ahead and try number 3 and number 4. My question to you, though, with number 3 is, what are you distributing to your work there? What is your a value? Hopefully you thought to yourself a is equal to -1 so that you can handle that appropriately. And you can check your work for number 3 and 4 either in OneNote or using Desmos like I showed you earlier. So great work, keep it up, hang in there, and let me know if you need anything.